I made my previous video about 10 times more difficult than I needed to. So Tibet's problem is all about the idea of a bullet coming through this piece of metal, and it has to go through 100 millimeters of length. But he actually knows that the attacker has a bullet that only goes through 180 millimeters. So obviously this piece of armor would not protect the person against that particular type of bullet. So they wish to slant the metal because then it'll protect further, right? So the idea is that the bullet comes in here on this one, and it's going to have to go further than the 100 millimeters. And in particular, Tibet wanted it to be, what did he say? He said 180 millimeters. So that was the protection we needed, at least this much slant to give us that much protection. And the angle that we wish is this angle right here. We want to find that angle down here, and let's call that theta. Now, since the width of the piece of metal is 100 millimeters, we can draw that in right here, perpendicular to this side. So this would now be a 100 millimeters on this side. And now, thanks to the fact that this blue line is horizontal and this blue line is horizontal, that means that the angle that we're looking for right here is actually congruent to the angle that's located inside of the triangle right there. And so the problem of finding the angle wished down here just turns into finding the angle in this particular right triangle that's drawn in green inside of the actual bar of metal. So notice that with that angle we have an adjacent side of 100 and an opposite, or no, a hypotenuse of 180. So therefore we could conclude that the cosine of that angle theta must be equal to the adjacent side over the hypotenuse, and thus theta would be equal to the arc cosine of 100 over 180, 5 over 9. There we go. I just drew the triangle facing the wrong direction. My fault.